Welcome to the Stormsurf video surf forecast for the week starting Sunday, May 26th. Looking at significant wave heights for the South Pacific Ocean, we see a gale, actually kind of a double-barreled gale, organizing in the central South Pacific, seas to 28 feet, but are expected to get higher, aimed reasonably well to the northeast, likely resulting in swell for Hawaii up into California. But even before that, there's yet other swell in the water. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when those gales form, help direct their track. We're looking here at the southern branch of the jet. That's the northern branch. It doesn't have much influence. It's the southern branch that really helps feed storms. We're looking for a trough, that is, winds pushing to the northeast, when you kind of get the sense that there's a trough organizing right here with, 120, 130 knot winds, gently easing to the northeast. Anyway, that trough is and will create a clockwise flow in the southern hemisphere, and clockwise in the southern hemisphere is the sign of low pressure. And of course, low pressure generates wind down at the ocean surface, and wind generates seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have sort of a trough, we'll call it, sort of a proto-trough. But then as we get into Sunday night, trough looks a little bit better organized. Doesn't take nearly as much wind in the southern hemisphere to generate or feed support for gale development as it does in the northern hemisphere. So we see, 100, 110 knot winds. That's about all it takes. Not a great looking trough, not a huge trough. It lasts into Monday, and then kind of peters out. See the winds feeding up into the trough right here. They get much weaker as we get into Tuesday. And then, theoretically, on Wednesday, another little batch of wind energy develops here in the far southeast Pacific. Maybe that would help generate something as well as we get into Thursday. But then notice this. See, we have a trough under New Zealand come Friday, but also a big ridge just to the east of it. That supports a counterclockwise flow like here, and that's the hallmark of high pressure. Certainly does nothing for producing swell other than wind swell locally. So you see this trough, very pinched, probably won't do anything as we get into Friday and Saturday, and we're left with pretty much a ridge pattern dominating the central South Pacific as we get Saturday into Sunday. Whoops. But then you notice, well, maybe a week out, just maybe, something in the New Zealand area might start to take shape. Also, pretty good trough here forecasting. In fact, let's go back and just take a look. Pretty good trough develops on Saturday. Now, California ends at about 117 west, so for the most part, this trough here in the far southeast Pacific will not do probably anything for California, but maybe for Mexico, Peru, and Chile. Too early to know, though. It's 180 hours out. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. Now, remember, this is a sort of a double-barreled gale. This was actually a previous gale here, fading with 35 knot winds. New gale developing behind it with 45 knot winds. So we get into Sunday, almost 50 knots in a little tiny area there by Sunday evening. That's this evening. And aimed pretty well, like to the north or northeast. That's good. Continuing into Monday, 45 knot winds from the southwest, and then by Monday afternoon and evening, the gale starts fading with 40 knot winds, and then even about the same there, but notice the gale starts falling southeast as well. Not so good, and these 30 knot winds just don't generate enough, impart enough energy to the ocean to make a long enough period swell to actually make it up into California. So, and no real hope there. We see the gale continue chugging into Wednesday and Thursday into the southeast Pacific. Also notice this here. I didn't see that before. Thursday, a little area, 40 knot winds southeast of New Zealand, but they fade out pretty quick. And this whole thing just doesn't look, here's the ridge building as we get into the weekend, doesn't look like it's supporting swell production. In fact, high pressure here, low pressure here. This is interesting. This low trying to build off the northeastern New Zealand coast. Not very big, not very long-lasting. Maybe some swell could result for Hawaii, but we'll see. We'll have to take a look at the wave models and see there. the pattern actually doesn't look as bad on these charts as what it looks like at the jet stream level. Let's go take a look at the wave models. All right, so here we are Sunday. We're actually going back in time. We're back a week ago, Sunday. A gale developed southeast of New Zealand. Small area of 30-foot seas. We lost about a day's worth of model run there due to some technical difficulties. But as you can see, as we got later into Monday, good area of 28 to 30-foot seas. This is Monday last week continuing, and then up to 32-foot seas into Tuesday, and then that system started slowly fading. Swell from that system is in the water, heading north towards California for the early part of the week. And then here we are into Friday, just a couple of days ago. And then here's when the first lobe of this double barrel gale started forming. 28-foot seas on Saturday to 30 feet. And not a whole lot more than that, 30 foot. And then here we are this morning, the second part of this system developing. All right, let's go take a look at the forecast. All right, so we knew on the charts that winds are supposed to build to near 50 knots. Tiny little area, though. We see 30, we'll call it 34-foot seas, building to supposedly 40 feet right here over an infinitesimal area, if that's the case. But, you know, good area, 36 to 38-foot seas, and becoming unshadowed relative to California. Some swell should result from that. Now, check out, we're just watching how much does this system move. We're going back to the northeast versus just to the east, and what you see is not a whole lot, and as you get into Tuesday, it actually starts falling south and kind of weakening. So that's probably the end of it. And then we're looking after that. Remember, we saw some sporadic, we'll call it troughs in places and fetch in places. This one little area northeast of New Zealand on Saturday, we're talking almost a week out. Tiny area of 30-foot seas. Good for Hawaii, probably not great for California. I mean, just these small fetch areas, you need much broader area of fetch to push solid swell to the north, and now we're a week out. So it looks like, in general, this system that's in the water right now, that'll probably be the last of it for a little bit, and then there's going to be a break. Quick look in the North Pacific. I mean, normally you wouldn't be looking this time of year, and there's this little gale here, sort of, call it northwest of Hawaii. Seas are in the, was that 12, 13-foot range? Not going to do anything for Hawaii. Though a similar one of these, a week ago, something like that, actually did produce a little bit of, officially we'll call it wind swell. It was an 11 or 12-second period swell. It pushed in the north shore of Oahu on, was it Friday and Saturday? Actually, fun-looking, rideable surf. Kind of a surprise, bit more than what was forecast. Anyway, so we're rolling out. We're out to Saturday next week. You can see it gets progressively quieter in the North Pacific Ocean. So we think officially now that we're moving into the full summertime regime here, and we'll get into more of that in just a second. Let's do a little inspection for wind swell production. So low pressure currently over Nevada, creating some weather in the Sierra. High pressure in the Gulf of Alaska, off of California. Actually, it's more off California than the Gulf of Alaska, but creating a pressure gradient. Two competing low pressure systems in close proximity to each other. Tighten up the isobars. That creates more wind. So 20, 25 knot northwest winds off of North California, producing wind swell down into North and Central California. Not so much trades pushing into Hawaii, not doing a whole lot for generating east wind swell. That's as of Sunday. We get into Monday. You see the gradient starting to fade as low pressure moves off to the east and the high kind of weakens a little bit. Generic 15 to 20 knot northwest winds start building on Tuesday. Yeah, maybe some little wind swell. As you get into Tuesday night, up to 25 knot northwest winds. Better odds for wind swell. Still really nothing for Hawaii. You want to see, yes, that's good. You want to see it closer to the islands and over a larger area. Anyway, Wednesday, yes, wind swell for California. It just sort of continues on. Thursday, here we go. There's some easterly fetch for the Hawaiian Islands. Maybe good for east wind swell along east-facing shores there. More wind swell for California. And finally, the winds let up along Central California, so all the fetches off of North California come Friday, and that, oh, there you go. There's a nice fetch for Hawaii. That's kind of what you're looking for right there. High pressure driving all this. Clockwise flow in the northern hemisphere. When we're talking 8 or 9 second period wind swell into the east facing shores of Hawaii, and about the same, maybe a little bit more, 9.5 seconds maybe for California. No particular big deal. Saturday, same deal. Actually, looking pretty decent for wind swell for California and Hawaii. And then we get into Sunday, high pressure fully taking control of the Gulf, 30-knot north winds. So you know where to go to find your wind swell if you're in Central California, assuming the model pans out and this is what really develops. A quick look at precipitation relative to California. Yes, there is. There's no real rain along the coast. It kind of shows it here, but we're not seeing any of it. In the Sierra, though it is snowing, chain controls were up for a bit. Snow flurries falling snow falling at Squaw. Probably not quite as intense as what it looks like on this chart. It's supposed to continue into the evening, and by Monday morning it clears out. And after that, with building high pressure and us being in the last week of May, the odds of any more additional precipitation, that looks like a cold front per se, it probably isn't going to happen. Summertime showers for the upper reaches of the Sierra, that's the more likely scenario, but California should start drying out. Quick look at the snow dashboard for Squaw. Yes, they're still open. All the snow happening right now, the next, we'll say 24 hours, say 6 or 7 inches possible at the highest elevations. That's probably pushing it a little bit. Temperature profile. This is the base of Squaw at about 6,200 feet. This is the top of Granite Chief Peak type area, 8,900 feet. You see the reds are above freezing temperatures, so we'll have cold temperatures into, what is that? Today's the 26th, so tonight is about it, and then we starting Monday into a warming temperature regime above freezing temperatures by the day after that, and continuing for the foreseeable future, and probably no change is to occur until probably next fall. So that's kind of it. Wind speeds, light wind speeds, no big deal. Let's go take a look at one other spot. Mammoth being a little bit further south, even less. We're talking, 3 inches of snow, but the same temperature regime. But they're higher, so it won't be above freezing temperatures the whole way to the top until maybe a week out or so, once we get into the second day in June. So, but same pattern setting up. All right, let's go take a look long term, see what's going on with the MJO and, of course, El Nino. As usual, we like to look for the presence of the active phase of the MJO, and the MJO travels on the equator from west to east. So this is New Guinea here. This is the far the East Pacific. This is West Pacific here. There's your equator, date line right there, 180 degrees. The arrows are 5-day average winds, and this is from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. And we see average winds from the east. That's pretty typical this time of year. In the East Pacific, once you get to the Central Pacific, winds start slowing down, and when you get into the far West Pacific, they're out of the west. Interesting. That's typically, so east winds or trades over the whole area, but when you see west winds, especially in the West Pacific, in what we call the Kelvin wave generation area, from 170 west, 5 degrees north and south of the equator, whole way over to 135 east, 5, and right in that box there, see west winds there. That's a pretty good sign of the active phase of the MJO. And the active phase of the MJO in summer months sometimes helps feed the jet stream in the southern hemi, but its correlation is much stronger in winter months in the northern hemisphere. Anyway, looking at anomalies, differences from normal for this time of year. Yeah, these east trades, pretty much normal. You don't see any directional significance here in the arrows. But when you get to the Central Pacific and the West Pacific, definitely strong west anomalies associated, we think, with the active phase of the MJO. And with that being the case, then that means there is a likelihood of enhanced support for gale development in the southern hemisphere. Quick look at what wind anomalies have been for the past since May 20th. So there's South America, Central America, equator, 0 degrees right there. Okay, there's New Guinea there, Philippines. The oranges and the arrows suggest west anomalies in the Kelvin wave generation area. Again, that area, 170 west, 5 degrees north and south of the equator. Just draw a box right there in your mind. That looks like the active phase of the MJO on the 20th, the 21st, 22nd, 23rd, and the 24th. So the active phase of the MJO, per this, looks like it's been going on for quite a while. Then we can go take a look back in time even a little bit further. Okay, this chart, you've seen this before. Whole planet on one chart. So the Pacific Ocean is between about 135 east and about 90 west. But the Kelvin wave generation area, the one we're really about, from there to about there, there's the date line, 180 west. We're looking up. So this is April 26th. In between these two tick marks here, you see the reds. That's westerly anomalies. That's the beginning of the active phase of the MJO in the West Pacific Ocean. It started about May 1st. Has continued the whole way through the month. Here's the 26th of May. Looks like it's going to continue for maybe 2 more days. Then you see the trend. The active phase moving from west to east on the equator, moves south of California and pretty much out of the Pacific by the end of May, early part of June. And likely you see some easterly anomalies, the blues starting to set up here in the Kelvin wave generation area. That likely means the beginning of the inactive phase of the MJO and less support for storm development in the southern hemisphere. So we can look at the strength of the active phase of the MJO. So this is phase diagrams. Assume you're looking that circle. Pretend it's the North Pole. You're looking down on the top of our planet, and the MJO moves on the equator from west to east, from the Indian Ocean over the maritime continent through the West Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dots where the active phase is right now, so we'll say somewhere in the Atlantic already. So the leading edge of the active phase is, already in the Atlantic. The west anomalies from it are still strung the whole way across the Pacific, but they will catch up as the statistic model predicts the active phase moving into the Indian Ocean 2 weeks out, and we'll say pretty weak. The GEFS model, initial starting point, the same deal, suggests the active phase barely making it into the Indian Ocean and then just completely collapsing. So the exact opposite of that, somewhere over here in the far West Pacific, is probably the inactive phase of the MJO. So you can kind of get the theme of what's coming. Here's the forecast for the MJO. All right, this is outgoing long wave radiation, sunlight reflectivity off the ocean surface. If you get a lot of sunlight reflectivity, the reds, that means the inactive phase of the MJO, no clouds. The MJO, when in the active state, is sort of like a big low pressure system, right? And that's what helps storm development and all that kind of stuff. But according to the statistic model, the inactive phase of the MJO is over the maritime continent, slowly seeping into the West Pacific. There's New Guinea. There's the dateline right there. There's the equator. You can see inactive phase taking over 2 weeks out. The dynamic model, saying basically the same thing. Looking here at the 15-day out reading, about similar in strength, a little bit of variation, but basically the models are in sync. Here's the 40-day upper level model. This is showing a propensity for precipitation. Oranges and yellows are suppressed precipitation, pretty much meaning the inactive phase of the MJO. And so there's New Guinea. There's the equator right there. Kelvin wave generation area roughly right around in there. You see inactive phase making its way across the Pacific into Central America on the equator by about June 20th, but actually this is about 5 to 7 days ahead of what it really does, so probably even late June. The next active phase starts moving into the West Pacific, 15th of June, so probably the end of June, let's say, and it does its thing. So here's where you'd be good to, if you're taking a trip or something in the Pacific, good time to go chase surf in the Pacific. But if you're going to the Indian Ocean, the active phase is supposed to be building through the early part of June. So you can kind of lay out in broad brush strokes what your probability is for success. So the Pacific, again, from, we'll say, mid to late June into middle of July, and after that, then another inactive phase starts setting up. And yet another MJO forecast and hindcast. So here we go. This is, again, the whole planet on one chart, Kelvin wave generation area, or West Pacific, between, we'll say, roughly these tick marks. And this is the future is down at the bottom. Past performance, here's April, and in April, we started with the active phase of the MJO. This is strong west anomalies, full-on westerly wind burst from pretty much the beginning of May the whole way to today. This was as of the 25th, but you can see the active phase of the MJO moving east out of the Pacific in the next 2 days or so. Now, according to this, the inactive phase right here, the dotted contour, is supposed to set up weak patches of easterly anomalies, but in general, a westerly anomaly pattern still continues over the Pacific, driven by this sort of weak El Nino pattern that's been in play for over a year now. Let's dig a little deeper. And then a similar chart, only this one's backwards. Past performance is down here. The future forecast is up here. Big westerly wind burst. You can see here's Kelvin wave generation area between these two tick marks going up. Occurred back in February. That created Kelvin wave number 3, which is erupting now, almost at its end. This is the new Kelvin wave that was created. Doesn't look quite as strong as the old one, but still we'll call it westerly wind burst number 4, but it's all but dead. Let's overlay the MJO. You can see there's the MJO as we go in time. Inactive phase sets up. Pretty much continues through later part of June. So June, for the most part, looks like a dud in terms of swell production. That's not to say that it won't happen. It's just the odds are not as favorable. Then we get into another active phase, we'll say late June through into pretty much the whole way into July, the end of July. So that would be, July is a good time to take a trip, it looks like, or, prepare yourself for surf then. This window, take care of business, do work, do whatever you got to do. And then as we get into August, again, another inactive phase. All right, let's overlay the low pass filter. Now, this is the interesting part. So this is the we'll call it our El Nino indicator. Okay, we were at 3 contours. We were actually stronger than that back some point earlier, but in 2018. But 3 contours. That faded out as we got into April. We're down at 2 contours. You see that fading out by the end of June. We're down to 1 contour. This is over the date line right now, right in the Kelvin wave generation area. But then as we get into August, this is what's a little concerning here. You see the contour moving out of the Pacific and into the Indian Ocean. And I'm hoping not to see one of these dotted lines start showing up here. But if it does, that kind of hints at a potentially developing La Nina pattern in the Pacific as we get late into the fall. My sense is, for right now, some sort of weak El Nino pattern continuing at least into the mid-fall, if not later fall. But maybe as we get deeper into winter, maybe El Nino will die at least, or move towards La Nina. That said, it still takes a couple of months for the true indicators to manifest themselves in the atmosphere, which means we're probably good through this calendar year, but sometime February, March of next year, perhaps some La Nina-ish pattern might start showing up in the Pacific. All right, so let's go take a look subsurface in the ocean, Pacific Ocean, on the equator, 2 degrees north and south of the equator. Here's the West Pacific. Here's the East Pacific. These little X's and lines right here, those are the sensors on the anchor lines of the TAO buoy array strung across the Pacific. So you can connect all the dots and build a profile of water temperatures, warm temperatures, 30 degrees centigrade in the West Pacific, 29-degree isotherm. It's been hanging around 160, 150. I mean, that's about the way it's been. This isotherm, the 28-degree isotherm line, made some progress almost into Ecuador, but it's been backtracking now to about 139. when you get a Kelvin wave, okay, so westerly winds, westerly anomalies associated with the active phase of the MJO, it's been blowing for a month now over here in the West Pacific, would take this warm water here, start pushing it to depth, and that warm water would theoretically, if it forms a Kelvin wave, would track east and then erupt somewhere in the Pacific, preferably along the coast of equator, but sometimes it doesn't make that far and it does it out south of California or something like that. All right, so, and the 4-degree isotherm line, still pushing well into Ecuador, but also notice it was down about 35 meters deep. Now it's up to about 20 or something like that. So the area of warm water in the East Pacific is getting shallower. All right, so here's anomalies, differences from normal for this time of year. You look at this, you go, well, it's not really saying a whole lot. And guess what? It really isn't. It's saying, yes, we have generic 1 degree above normal centigrade temperatures. That's, what, 1.5 degrees, degree and 3/4 Fahrenheit above normal, seeping out of the maritime continent, filling the entire equatorial Pacific, not quite pushing into Ecuador anymore, and maybe a little pocket of 2-degree anomalies there. So that certainly doesn't look like a defined Kelvin wave at all. In fact, Kelvin wave number 3, generated by that big westerly wind burst in February, has, for the most part, completely erupted. We're looking, since we have westerly anomalies that have been blowing for almost a month here, for maybe a Kelvin wave number 4 to show up. We'd like to see like 2-degree anomalies, 3-degree anomalies showing up here, but we're not seeing it. We're wondering if perhaps there just really isn't enough warm water left over here to support, Kelvin wave development. Let's go look at another model. Here we go. Here's yet another version. This paints, the real thing that catches our eye here is cold water erupting to the surface, suggesting that Kelvin wave number 3 has completely done its thing other than this little pocket here off the coast, and cool water coming up from depth. Now there's still this broad pocket of 1, 2, I'll call it 1 degree above normal anomalies from north of New Guinea to about south of California, something like that. But at some point over the next 2 to 3 months, that will all bleed to the surface or erupt and disappear, and then that sets you up for La Nina, unless we were watching warm anomalies building off of here, but this past 5 days, they have not been present at all, suggesting that maybe the warm pool over there in the West Pacific is tapped out. Here's sea level anomalies. Basically what this is, JSON 2, JSON 3 satellite data. Strip out all the waves, strip out the wind waves, strip out the tides, and we're looking for a bump on the ocean surface. We're not seeing it anywhere. It'd be yellow if it were, and specifically right here on the equator, because that's where Kelvin waves, they travel from west to east, only on the equator. Instead, we're seeing below normal anomalies, minus 5 or 10 or maybe even more. So that suggests cold water at depth. That's kind of maybe the upwelling phase of the Kelvin wave cycle, or maybe the sign of something a little more ominous. Too early to know. We do have some warm anomalies here on the date line, 0 to 5 centimeters, meaning maybe a Kelvin wave's trying to organize, or maybe not. It's not a strong indicator one way or the other. But generally, all this past year, there's been warm anomalies all here. They're all gone. It sort of suggests that the Kelvin wave cycle is tapped out. Here we go. Upper ocean heat anomalies. This is the West Pacific here. This is the East Pacific here. You can just watch basically warm water, where it's going, what it's doing. This was Kelvin wave number 1 back in June of last year, going from west to east. Upwelling phase of the Kelvin wave cycle. Stronger Kelvin wave number 2 last fall, going from west to east, driven by, of course, westerly anomalies in the active phase of the MJO. It tapped itself out. Upwelling phase of the Kelvin wave cycle. Here's Kelvin wave number 3. It started in January. It's that big westerly wind burst really in February. That's what kicked it off. And there you see warm anomalies, and it's pretty much faded out. Upwelling phase of the Kelvin wave cycle, that cool pocket that we're seeing at depth, that's probably what it is. But the issue that's bothering us is cool anomalies in the West Pacific. Notice they weren't there before. This is when we say we think the Kelvin wave cycle is sort of tapped out. You can have all the westerly anomalies you want, but if you don't have warmer than normal water in the West Pacific, there's nothing to push off to the east. So we'll monitor that. And this chart, in a very gross way, tells you the same story. Upper ocean heat anomalies is from the date line off to a point, south of Mexico. But there has been this steady pool of warm water, and as of May, it's all but disappeared. So let's go take a look at the surface. Now here's where things get really interesting, right? That cool pool was erupting somewhere around here, I think. But you notice reds. This has built tremendously in the past week. Solid, upwelling of warm water. We're thinking this is the last kind of the Kelvin wave cycle, but just off the, look at it, you go, my, looks like El Nino. If you'd ever expect to see an eastward displaced El Nino, this is kind of what you'd expect to see from the start of it, but we suspect this is more of a red herring than anything. But for now, good warming off of Peru, Ecuador, Colombia, all up the Central American coast, off into Mexico, just filling this area and bleeding off to the east. Remember, trades are blowing here, so this is surface temperatures, so that'll all eventually be migrating off to the west into the official El Nino monitoring region. This is in what they call Nino 1.2, this area right in here. The official El Nino monitoring region, Nino 3.4, 5 degrees north and south of the equator at 120 west. So a box out to about 170 west. So this warm water at some point will migrate to the east, to the west, driven by trades. The trend, 7-day trend, see blue showing up off of Peru and spots out here. It sort of does this curve thing this way. Looks like cooling right here. Now the other thing is, notice cooling off Africa. Sometimes you see this. It's not at all 100% correlation, but sometimes you'll see cooling developing here, and then it'll show up here. Or you'll see warming here, and sure enough, it'll show up over here too, just driven by winds and wind patterns. So this has been going on for probably almost 2 weeks now. It kind of comes and goes. Then we got our warming. It's just 7-day trend right here on the equator. So it's kind of a mixed bag. Cooling over here in the far Nino 1.2 region, but warming or at least steady in the Nino 3.4 region. Looking at the big picture, yes, you see there's little shades of cooler water. This is anomalies, differences from normal for this time of year. El Nino, you want to see a big old anvil of warm reds right in here if you got a strong El Nino. We don't have that. This is, again, this sort of weak Modoki El Nino pattern. Most of the warming is centered here in the central Pacific. So that means the Kelvin wave, the westerly anomalies were not strong enough. They didn't last long enough in this area here. Kelvin wave generation area, we'll just draw a box right there so you can see it like that. Okay, you get westerly winds as the active phase moves from the Indian Ocean, actually probably more like that, to the West Pacific, takes warm water all here, dumps it into the Pacific. More west winds push it to depths, forms a Kelvin wave. If the Kelvin wave has enough velocity, it can make it the whole way into Ecuador, and then it hits land here, basically, and gurgles up to the surface, and you get this big old warm slick here. But all of our Kelvin waves, the 3 or 4 that we've had so far, all make it about to here, and then they just sort of leach to the surface. They don't have a lot of energy with them. There's no strong marked warming signature. And so we've ended up with this really kind of anemic looking El Nino type pattern for the past year. Water temperatures in the Nino 1.2 region, yeah, they're up. No big surprise. You can see it on the charts, up to 1.174 degrees above normal. So that's pretty good. And compared to the past couple of months, the highest it's been so far. In the official El Nino monitoring region, though, a slow, steady decline. We're at half a degree, 0.520 degrees above normal. Not particularly inspirational. El Nino, you have to be a half a degree or better for 5 consecutive months, effectively. Yeah, we've reached that threshold, but just barely, and if anything, it looks like we almost fell behind a little bit. We're just barely hanging on, so not a strong El Nino, as most everybody knows. So what effect are these warm waters, weak warm waters on the equator in the Nino 3.4 region having on the atmosphere? Well, one way you can do that is measuring or looking at the Southern Oscillation Index. Here we go, SOI. Difference in pressure between Tahiti and Darwin. When the index is negative, it suggests the active phase of the MJO. And today we're at minus 19.28. Pretty good. Suggests the active phase of the MJO. It's been like that negative for about 8 days. And actually, much longer than that. You can pretty much see somewhere around May 6th. From that on, it's been negative other than a couple of minor aberrations there. The 30-day average, that takes some of the noise out of it, has been holding steady. It's at minus 5.45 today. It was down at minus 6.88 at one point. So, not really going anywhere. The 90-day average, minus 5.16. It was down actually deeper, down to minus 7.8. There we go, 7.87 in mid-May. So it's lost some ground, suggesting this. So this is more like the El Nino indicator, the 90-day average. The 30-day average is the MJO indicator, suggesting sort of a neutral, active MJO pattern. This suggests sort of a very, very weak El Nino pattern, and at that, fading. The forecast for the sea surface temperatures for the Nino 3.4 region have taken a dive this week. Not nearly as strong as what they are forecast, but this looks way more realistic as to what's going to happen. So we were at about 0.7 a degree above normal in May, and going into June, and then starting June, a slow decline sets in. Maybe 0.4 of a degree, 0.4 of a degree, not El Nino range anymore. So we get into August, September, October, fading from there down to neutral in January. So this is the real unknown here is, remember we looked at the one chart and it said, oh, the low pressure bias was going to move out of the Pacific and into the Indian Ocean, suggesting maybe La Nina. But this chart here suggests, or this model is suggesting, well, sea surface temperatures just to stay neutral, maybe a quarter of a degree above neutral, which is not El Nino, it's just nothing, which that's still way better. If we just go into a neutral regime, and this really the key, if we go neutral and stay there, that's fine. If we go La Nina, that'd be no good. But the time to really look for it's the February-March time frame. If you're going to go one way or the other strongly, that's when it will manifest itself typically in the atmosphere. So we still got a ways to go until the model gets out far enough, really has a handle on what's going on. So for now, though, we'll say ENSO neutral long term. So to wrap things up, southern hemiswell. There's actually southern hemiswell in the water right now, sort of a precursor from New Zealand. The first real New Zealand swell hitting, I think it's Monday or Tuesday, something like that, in California, and some bits of it are already hitting Hawaii. Another one forecast behind that, but then after that, things kind of really settle down. The inactive phase, the MJO, is supposed to take over. That'll probably dampen the storm production machine in the southern hemisphere for a month. That doesn't mean there won't be southern hemiswells. There just won't be as many or as strong or as powerful or anything. And then maybe when we get in July, things will waken up again. Long term, El Nino looks to be fading steadily. We're not seeing anything that suggests it's going to build. All the data suggests weakening. The unknown is, will we go to La Nina or will we just fall to neutral? Either way, it probably doesn't matter for the coming winter, but as you get into, let's say, March, almost a year from now, that's when we'll know where we're really at. So, get the surf you can. Make the most of it. There's still snow. Go skiing. It's actually not bad. And have some fun. We'll do this again next week. Same time, same channel. Thanks for watching.